United States, we have a problem. Too many areas and communities are not accessible by mass transit. So many areas in this country are not accessible by mass transit, which is really detrimental to many people who rely on mass transit to get around, or who cannot get around by mass transit because it's not being served in their communities. And people who cannot get around by mass transit because of their either disabilities or inaccessibility to mass transit would be forced to buy a car or forced to use a car. And many people who are unfortunately unable to afford cars, unable to use a car, and some people can be homebound because of this. But putting that aside, many students who live off campus drive cars because it's more convenient to them. It's more convenient for them to drive cars. And unfortunately, personal transportation is responsible for a bulk of carbon emissions. Public transportation, on the other hand, is much better for the environment because many people would ride a single bus. So your carbon footprint would be much lower. Here in Oswego, not just the city of Oswego, but the town, and in central New York, there are buses, but they don't serve areas that need to be served. I live on one of the main roads leading to campus, and I bike there. That's my bike right over there. I could have gotten a car, but for one, I don't want to contribute to the climate crisis, and two, I cannot afford a car because I am low income, and I am also disabled. So instead of having students drive to campus when it's only 30 minutes by walk or 10 minutes by bike, there should be a bus that would be serving those students who live off campus. There's a lot of off-campus housing by the school, and Centro hasn't really been serving the area. And I think there have been other students who complained to the Student Government Association, but I'm not sure. But I'm going to bring it up to them and explain to them my situation. The description that I wrote about how dangerous it is, I wrote that last night. This morning on my way to class, I almost got hit by two cars. One, the first incident was a pickup truck that went into the shoulder when I was on my bike, almost forced me to go into the grass. The second incident on the same road, about 20 seconds later, was a car that was turning on the right lane, making a right-hand turn. Thankfully, they saw me and broke hard. But just today, within 20 seconds, I almost got hit by two cars. The first one was the scariest because that car was going about 50 miles an hour in the opposite direction because I was going down the hill. Car was going up the hill at near full speed. Had I been hit, I would not be here right now. This is the danger that I'm talking about. And after classes end, when I start going home, and now that it's getting late, it's going to be the sun is going to be setting earlier. I'm going to be biking home in pitch black darkness. There are no lights once you get off campus, and it is pitch black, and it's frighteningly scary. And I am not the only person that does not have a car that lives off campus. There's a couple other students that walk or bike to campus, to and from campus. By having a bus serving that area, most of the students who would otherwise drive their cars to campus would have a viable alternative, and that would lower carbon emissions. Another thing that I want to discuss is America's lack of accessible transit. For instance, the cargo rails, almost all of the rail in the United States, the cargo industry, the train cargos, those cargo lines, so much track that Amtrak has to borrow those rail lines. While Europe and Asia are far ahead of the United States in using high-speed, low-carbon electric trains, America uses slow diesel trains which emit a huge amount of CO2. While still it's better for the environment than cars, America's slower trains emit far more CO2 than the trains in Europe that go at 3 to 4 times as fast. So it is imperative that America invests in high-speed rail, especially in the big in high trafficked areas where there's high amounts of vehicle traffic. You know, it would take a lot of the vehicle traffic off the road, encourage more people to ride trains and buses instead of drive or fly. For an instance, there was a plan I read in Popular Science to build a high-speed rail line between New York and London that would utilize Greenland, go over the Arctic, and then into the UK. That would be subterranean. It's called evacuated tube transport, where all the air will be sucked out of the tunnel and allow for those trains to reach hypersonic speeds of over 2,000 miles per hour using very little energy, just electricity, a maglev train. While it's expensive, it is possible to build that kind of line only for about $30 to $40 billion.
Oh, okay.
Yeah, it's only my class.
Oh,
I'm pushing. Do you need a permit?
That's a good question. I don't know.
Yeah, I live in the town of Oswego, not in the city.
Yeah.
I live right off campus. I almost got hit by 2 cars today.
Oh, nice.
So the description I wrote about how scared I am of commuting to and from campus by bike was last night, and this morning I literally within 20 seconds almost got hit by 2 cars.
Good Lord.
Yeah. I mean, I don't want to have a car. I really don't. It's too much work. It's, expensive, bad for the environment.
Yeah.
I just think Centro needs to expand to off-campus, just to that one area, maybe the 1A or the 2A bus. I don't want it to get to that point. I don't want another tragedy to happen. I already realize how dangerous it is, but this is not why I'm doing this. Like, this is a secondary reason. Even though I put it as the prime reason, the real reason is about climate change and about how not enough is being done. Like a lot of these car industries are saying, oh, we'll go all electric in 2030. That's not fast enough. There's ways you can manufacture batteries that are far better for the environment. For example, graphene. There's carbon-based batteries that are recyclable, that are compostable. It would last decades. So you know what graphite is? The things you use in your pencil? Yeah. That has more energy potential in a battery than anything we've ever used. And it would make renewable energy king. It would, it's great at storing energy, transferring energy, charging. You could literally, with a graphene battery, if you had 2 graphene batteries, you could charge and discharge in less than a minute. It'll be just as fast as filling up a gas tank. Maybe not as fast, but close to. And it wouldn't be like 30 minutes to charge a car, like those superchargers. It would be even faster. And it would make electric EVs very, very practical. And they're solid batteries, so they're not dependent on heat or cold like today's lithium-ion batteries, which are a hazard. Explosive, toxic chemicals. Lithium-air batteries are good, but graphene are better because there's no harmful byproducts. It's just carbon. And you're literally trapping the carbon in a battery. You're using carbon to not pollute carbon, And it's the best thing for the environment. And here's the thing, coal that we burn every day, polluting so much carbon, is what, believe it or not, is if you don't burn coal, you could actually turn coal into graphene and graphite, which would be perfect for energy storage. So stop burning coal. That's the thing, stop burning fossil fuels. So do you work here for the city of Oswego?
Yes, I do.
What do you do?
I'm nothing important. I'm records.
Yeah, I'm not really. I'm a broadcasting major, but
yeah. I was say when I was at City Swing, I was a poli-sci major. I was say everything you've been talking about is stuff that I had classes on, stuff that I had to make.
Problem is, in America, the entire rail industry is owned by corporate rail, private rail, and it's not allowing, efficient, high-speed rail. Like Texas is building this. What is it called? Houston to Dallas rail, but it's like falling behind. Like it's taking private companies, which is a disgrace, to do anything. Almost all rail companies and high-speed rail is done by the government.
Yeah.
Believe it or not, socialism is actually a good thing if it's done the right way. Like Europe does it the right way. Why can't America do it the right way? I mean, because America is too capitalist. You know, you're literally penalized for working. Like if you're on welfare and you're poor and you need extra money to work, because let's say your house is too expensive, you lose your welfare and then you're on your own. It shouldn't be like that. In Europe, they look at how much you're making, but they also look at your situation. But everybody gets free healthcare and education. But if you're struggling, they will help you. And how do they do it? They don't have a huge military budget. Why are we going around telling other countries what to do? You know, here's what we should do instead. Like if America wants to do anything, it should be helping other countries industrialize. Like Africa, you know, instead of having them industrialize through coal, have them industrialize through renewable energy, wind, solar, geothermal. You know, like I know we have 2 nuclear power plants down there.
Yeah.
You know, what would happen if an earthquake hits and a tsunami hits? You know, you would have a meltdown. There's a form of nuclear energy that wouldn't do that, but unfortunately, there was only one it was an experimental reactor. It was called the molten salt reactor experiment in Oak Ridge National Laboratories. That nuclear reactor would not have had any meltdowns. It never melted down. They even did experiments where they shut down the reactor, and instead of overheating and melting down, the fuel is already molten. It operates at really high temperatures, so the nuclear fuel is molten, hence the name molten salt reactor. And the salt is a modulator. It modulates the temperatures. It acts as a not a coolant, but as a modulator. So as the temperatures increase, the salts expand, which would decrease the amount of nuclear fuel in the reactor. That would cause the reactor to naturally slow cooling down, and then the salt would shrink and the reaction would become higher. Because they were looking at the reactor, you know, when they first started it, the temperature would go up, then it would go down, it would go up, and it would always oscillate. It would always be at within a certain range of temperature. And and the salts, which would be Fleib salts, Flaib, would work as a modulator. But the only issue is corrosion. You know, salts corrode metals. So they're looking, how can we, you know, because lead, salt would corrode lead. So they're trying to find a way to coat the lead in some sort of salt-resistant coating, heat-resistant coating. That's the only issue. But beside the corrosion, this reactor consumes nuclear waste, meltdown-proof. So it doesn't just consume its own waste, like as fuel.
Yeah.
All the waste we've accumulated from today's ancient reactors that have been based on 1930s and 40s technology would also work. You could literally use all the nuclear waste and it would no longer be waste, it would be energy in the reactors. And it fissions 99% of its products, molten salt reactor, liquid fluoride thorium reactor, 99.9%. And the 0.1% that's left over is usable. Like, we need those stuff. Instead of, not waste, like useful products, like bismuth for cancer fighting, plutonium-238 for batteries. It doesn't produce 239. The 239 is what causes is the more dangerous one. What's used in nuclear bombs. 238 is perfect for electricity production in space rovers. But most important is the cancer-fighting properties. Instead of multiple decays, bismuth-213 decays once, so it wouldn't cause radiation sickness.
So, check, you say you're a broadcast major?
Yeah, I mean.
Holy crap!
Well, yeah, I've done a lot of research over the years about the climate change, about nuclear. I used to be anti-nuclear. I still am. I'm anti-current nuclear. Today's nuclear technology has got to go. It's not safe. In fact, they're still building new nuclear technologies that's based on water as a coolant and pressurization. What would happen if you lose coolant, if you lose pressurization? You would have a meltdown. Look what happened in Fukushima. That's just, and now they're releasing all this radioactive water. There's ways to do nuclear energy. Molten salt reactors are the future, but they should have been done since the 60s. But the problem is it didn't produce weapons grade materials, so Nixon axed it. You know, no waste. I mean, it's It's perfect. You know, if it's being used in conjunction with renewable energy such as wind and solar and geothermal, you can have a carbon-free, not carbon neutral, carbon-free society, or even negative carbon. It's entirely possible. But oil companies don't want it, energy companies don't want it. But it's what we need. It's practical.
Yeah.
To build a 2,000 megawatt nuclear power plant would cost about $10 billion. To build a 2,000 megawatt LFTR, you need about 20 of those reactors, right? Because they're small, they're modular. It would cost about $100 million per each reactor, about $1 billion. So imagine instead of calling, no, not 100 million, like $200 million, because that's based on 2010 numbers. So $200 million per each reactor. That's just my estimate. And it could be built in an assembly line. So no cooling towers necessary, no pressure vessels, none of that. So it would cost about between $100 and $200 million per each reactor. Each reactor would produce about 100 megawatts of energy. So 20 of those reactors would cost about $2 to $4 billion to produce the same amount of energy as a $20 billion, $30 billion nuclear coal-fired power plant, because coal power plants also need cooling towers, by the way. And also coal plants actually release more radiation into the atmosphere and mercury than nuclear power plants. Nuclear power plants don't release radiation into the environment unless an accident happens. So for a coal-fired power plant releases more radiation into the atmosphere than nuclear plants do. That's actually true. It's because there's radiation on the ground from decay of radon, from decay of uranium.
So I have to get going. I'm sorry,
Thank you.
but I'm gonna be real with you. It sounds like you're in the wrong major. It sounds like you should be.
Oh no, I'm bad in math and physics.
Okay, that's
that's
fair.
the issue. That's the issue.
Fair.
I have dyscalculia.
Okay.
And I have issues with formula, like remembering formulas, and they make all the students, even disabled students like myself, do closed book exams, and I can't.
Okay.
If exams were open book, I'm not saying like the answer would be in front of you, but if I just looked at the steps, I would be able to get them and how to apply them correctly. But unfortunately, they expect all the students to know it like that. Like that's really ableist for,
That makes more sense then. Well,
there are schools that for students with autism, but it's really expensive. There's a school in Vermont, but it's way too expensive.
Well,
thank you so much.
I'll say keep it up. Try to get other people in on this.
I mean, I did get to Calc 2. I do have Calc 2, but it took me so many tries, and I took Calc 3 about 3 times, physics 3 times. I just realized, and I never went to high school. That's kind of the reason my parents sent me to a special ed school. So I never really got the math. Yeah. But I did a lot of self-teaching. A lot of what I know is self-taught, especially weather, looking up computer models. Like I know how to read the plots, the skew T plots that show you temperature and dew points. Like I even know how to calculate Celsius to Fahrenheit since I was only 8 years old. The only issue is that with math and physics, it's just too many formulas. Thank you so much.
No problem. And like I said, keep it up.
Thank you. Yeah, as I was talking about molten salt reactors, liquid fluoride thorium reactors, while they are nuclear and they are, it is radioactive, thorium in itself, so if the thorium gets put into the reactor and then it's fissioned, it's hit by a proton, but thorium itself, thorium-232, is very inert because its half-life is over 4 billion years. The longer the half-life, the less radioactive it is. Thorium is one of the most common elements in the Earth's crust. The only thing more common than thorium is lead, which is actually a neurotoxin. Thorium is pretty harmless. Like you won't get sick from it. You could have a piece of it in your pocket and you won't get radiation sickness from it. Problem is, it's considered a byproduct in a lot of mining operations. And I used to watch this YouTube channel called Gordon McDowell. He's a thorium advocate, I used to be anti-nuclear entirely. I still am for the most part, with the exception of thorium and fusion. But fusion is really impractical because of, that we don't have the technology for it. But molten salt reactors, the 4th generation reactors, will be a great transition from fossil fuels to carbon-free energy, especially. And also by doing graphene, we potentially won't need nuclear at all, because we could store energy very efficiently by using carbon to not pollute carbon. Unfortunately, the lithium mining industry is really harmful for the environment. And also there's a lot of, unfortunately, child labor that's being used in the in the production of lithium, especially in Africa. It's really, really unfortunate. And also China has a lot of lithium mines as well. America does too. We have a lot of lithium, but for environmental protection reasons, we're not mining it. But what we're doing is we're outsourcing it, and we're having other countries mine it for us, which is really bad. Instead of mining lithium, there's already been enough thorium extracted from the earth already that we could power the planet for several hundred years at current energy levels. And that's not even including the waste that we produce, just the thorium that's been mined. There's so much thorium on Earth. 1 ton of thorium, just 1 ton could power New York City for an entire year. The world has millions and millions of tons of thorium. Moon has hundreds of thousands of tons of thorium. Mars does as well. It's available everywhere in the solar system and in the universe. It's not like it's rare earth. It's not a rare earth. It's a common earth element. It's even more common than uranium-238. Problem is, we're fissioning uranium-235. All the nuclear power plants we have use uranium-235. And it's an oxide fuel, which is a problem, because at high operating temperatures, if it overheats, it melts down and you have a reactor core meltdown. Thorium, on the other hand, in itself is inert, so you have to breed it into uranium-233. But here's the thing: uranium-233 is more radioactive than 235. But there's a major but. It'll already be in the reactor from when it becomes 232, or when you put thorium-232 and then turn it into 233. That would take about a month. So it takes a month to breed the thorium into uranium. So the thorium-232 would become thorium-233, then the thorium-233 would become protactinium-233, and that then would become uranium-233. Not protactinium, protactinium, I believe, 233. That's the thorium decay chain. And then you would get uranium-233, which you would fission in the reactor. And whatever's left over can also be fissioned in the same reactor as well, because it's a molten salt reactor. And you won't get any dangerous side effects from it. Like any bubbles that could build up would be bubbled out of solution, like xenon gas, for an instance. Xenon gas was one of the contributing factors to the Chernobyl meltdown in 1986, but it was also because they used graphite-tipped rods, and the graphite tip, when you put it in water, had an uncontrollable reaction. What they should have done is they should have gone with molten salt reactors, and America was the one who spearheaded the molten salt reactor experiment in the 1960s for civilian energy, because they knew that it would not produce weapons. They knew it. And the Kennedy administration, and I believe the Eisenhower administration, tried to pursue it. But unfortunately, Nixon in 1972 canceled the program because it didn't produce weapons-grade materials. That was the reason. Because we were in the Cold War with Russia, well, Soviet Union at the time. We could completely go off carbon if we use renewables and use molten salt reactors. And molten salt reactors were meant to be used in outer space where there's no water. It was designed for lunar colonization. Kirk Sorensen is the one who discovered it. He was working with NASA and that one of the things they were researching, well, not he was doing, but he found archives. It was initially started as a nuclear-powered plane experiment in the 60s, and the molten salt reactor. But they found that really it has great uses for civilian technology and for possible space exploration. I think it would be great for solving the climate crisis. Of course, it's not going to be a silver bullet, but it is going to be a big way that many industrializing nations, especially in sub-Saharan Africa, countries like India, could use without emitting huge amounts of carbon. Because the concern is, as more developing countries would try to industrialize, they're going to get a massive boost in coal, massive boost in just fossil fuels, and yet there is a way to go away from it. In fact, there was a book called Cheaper Than Coal. Thorium can be produced at really cheap rates, as cheap as 4 to 5 cents a kilowatt hour, lower than coal, much cheaper. You think coal is the cheapest? No, it's not. It will be molten salt reactors because of how common they are in the Earth's crust and how easy it is to operate and safe. First of all, it's safety. Second of all, it's operating costs. Third of all, the third thing is molten salt reactors would be perfect for a country like France where it's government owned. Because then it would be, or you would get, there would be less greed.
Everybody take Monday off.
So yeah. However, I think instead of investing more in nuclear, we should still invest more in renewables, especially geothermal energy.
No.
The problem with wind energy, it's great for the environment, but it's also bad for birds. It's a hazard for birds. And solar plants, unfortunately, its byproducts are very harmful for the environment. And there's a lot of people that get sick from the manufacturing of solar plants because of the chemicals necessary. With molten salt reactors, with liquid fluoride thorium reactors, LFTRs, that wouldn't be a problem. There was only one ever constructed, and Norway was also building a thorium-based reactor, but it's not a liquid fluoride thorium reactor. That's the problem. I know about Bill Gates' plan to build a traveling wave reactor, but again, it's not really practical. I think the best course of action is to go with molten salt reactors, especially liquid fluoride thorium reactors for nuclear energy. And for renewable energy, I believe the best is geothermal or wave-powered energy. And I think the best form of wind energy would be offshore wind. And I don't care about, it's an eyesore. What would you rather have? An unlivable future or a little visual discomfort? Exactly. We need to invest in going off of carbon. We need to completely get off of carbon as soon as possible. Not in 20 years, not in 30 years, but immediately. We need to start divesting away from carbon and towards other alternatives and safe alternatives. I understand a lot of people want to build more nuclear power plants, but you can't build technology that's been proven unsafe. We've already had enough nuclear accidents with current nuclear technologies. Fukushima, 3 Mile Island. Not to mention the 1957 reactor accident. We need to build safer reactors that are proven to be safe. Molten salt reactors are proven safe. So let's build thorium molten salt reactors. Specifically the liquid fluoride thorium reactor. And also we should invest in fusion energy as well. Invest in building high-speed rail, electric high-speed rail. Invest more in wind, especially in areas that are not prone to bird migrations. When you build wind turbines, make sure that they're not in the path of bird migrations, because that would be harmful to the biolife. So when we're trying to fix the climate, we need to make sure we're not harming anything else. Like, we're not fixing one thing and messing up something else. We need to make sure that whatever our actions are, we're not leaving behind a big footprint. Nuclear energy doesn't really leave behind a huge environmental footprint unless something happens, but the risk with today's nuclear technology is too great. There are other alternatives, but when people hear the word nuclear, they automatically assume the worst. Fukushima, Chernobyl, nuclear meltdown. So here's how a molten salt reactor works. So you have the reactor, not pressurized or cooled, because you don't need pressurization or cooling.
I go, yeah, so?
So the water would only be used to turn the turbines. A little water.
Tell me about my job. I go, seriously, because I go, not this shit.
Plus, you can't even really, like, even if, look at how long it took.
And
So even if
say you would lose power to your reactor. At the bottom of the reactor, there is a piece of frozen salt that's being kept frozen by cool gas that's being blown on it, right? That would melt, and the nuclear fuel would drain into a separate container that's located below the reactor. So a separate drain, it's called a drain tank. And the drain tank would then, the nuclear fuel can be reused at a later time once power is restored to the reactor. No accident, no meltdown, no environmental damage at all. And even if you were to have, let's say, someone sabotaged the reactor, once the fuel would escape from the reactor, it would immediately solidify. It's a practical and safe alternative to today's nuclear technology. But I just said a worst case scenario. And here's the thing. Uranium-233 emits gamma radiation. So if someone tried to weaponize uranium-233, they wouldn't. Because immediately nuclear detectors from hundreds of miles around would go off. And, the transportation of it would be impossible. And also, it's only been used once in a small atomic bomb back in the 50s, but it created problems because it messed up with the electronics of the bomb, and the bomb couldn't really fire. So they stuck with uranium-235. Uranium-233 is, of course, very exploitable for nuclear weapons. 233 is not. Thorium, you cannot really use it for nuclear weapons. Uranium-235, yes. Uranium-238, I believe also yes. Because both decay chains can lead to plutonium-239, which is a trigger for nuclear, is the trigger you need for a nuclear bomb. Plutonium-238, it's not powerful enough to trigger a nuclear explosion. So weapons proliferation risk is non-existent with molten salt reactors. With thorium-based reactors, non-existent weapons proliferation risk, and near non-existent risk. About 99% less of a risk than today's reactors. So if a country was building these reactors and not building the reactors we have today, they're most likely pursuing civilian technology, civilian reactors, and not civilian. Like with today's civilian technology, with today's reactors, you could actually enrich the uranium to make a weapon. With the thorium reactors, you cannot. So it gets rid of the meltdown risk, the weapons proliferation risk, the waste issue. It gets rid of the waste issue. No waste, no meltdown, almost no weapons proliferation risk, and it is perfect for cancer-fighting isotopes. Bismuth-213. It is perfect for blood cancers like leukemia, especially non-Hodgkin's leukemia. without having to go through chemotherapy, which is extremely draining on the body. Bismuth-213 decays once. So it would just target each individual cancer cell instead of targeting healthy and unhealthy cells in the body. So I'm going to be here until 6. My phone's about to die, but I will be here every Friday from 2 to 6. So next Friday I'll be here at 2. I'm not always going to be live streaming. And we also need to invest more, as I said, in renewable energy, especially geothermal. Wind is the next best. Solar, I'm not a big fan of solar because of the waste, the harmful byproduct. Especially, it's really harmful for the workers who make it. And we need to find alternatives for electric vehicles. For instance, using graphene instead of lithium. Because you're never going to run out of graphene. And there'll be much less, even if you do need lithium for graphene batteries, like it's just for the coating, not for the interior part of the battery. And also, you would need a lot less metals. Yep, so it's about 5:30 right now, so I'll be here for about another 40 minutes. Also, for those of you who are from Oswego, last winter, Oswego had the least snowiest winter on record. And I was here for it, and I was really disappointed because I love snow. I love snow, and we need more snow to reflect the sun to cool down the planet. Now it would take a massive above water volcanic eruption, more powerful than Hunga Tonga, to create any cooling effect. But guess what? If we try to geoengineer, such as releasing sulfur into the stratosphere, we would be harming the ozone layer. So instead of trying to find workarounds, we need to stop polluting carbon. We need to plant more trees and help phytoplankton bloom in ocean deserts. We need to work with the planet, with nature, and not against nature. We need to work with Mother Nature, not against her. And also, by using molten salt reactors, we could stop cutting down forests for firewood, cutting down forests for using wind energy. Wind energy you should never cut down trees or forests for wind energy or for solar. For instance, when I was in Iowa, I noticed a lot of corn farmers allowed energy companies to install wind turbines on their property. I think that's the best course of action. Instead of use the Great Plains, which is just a huge wind area, to install wind turbines on people's property. Of course, pay them, and that way you're reducing your reliance on fossil fuels while not harming nature. So it's a win-win situation. States like Iowa and Texas are doing it the right way. But the problem is they still use coal as their secondary energy source. We need to get rid of coal entirely and replace it with nuclear energy and geothermal energy. And when I say nuclear, I don't mean that type of nuclear. Let me just demonstrate what I'm talking about. All right, I don't know if you can see this, but a lot of times there's 2 nuclear power plants over there. So it's 9 Mile Point, I believe. There's 2 reactors over there, about in the town of Scriba. And those are what are known as pressurized water reactors. Those are 1940s technologies and are unsafe. Well, yes, they don't pollute carbon, and they are better for the environment. And nuclear energy, even with all the meltdowns throughout history, only killed a few thousand people. Still not good. It's not good. Every nuclear power plant in existence, every year from air pollution, not from climate change. This is not related to climate. this is just from air pollution. Every year, 4 million people die from outdoor air pollution, from lung cancer, from, side effects of, birth defects. 4 million people die from air pollution, outdoor. That doesn't include indoor air pollution from like heating, from using kerosene or using coal or using wood. Total air pollution deaths around the planet are around 7 to 8 million a year. So yes, nuclear has fewer fatalities, but the risk is kind of great. So molten salt reactors are the way to go and are the future for developing and developed nations. I strongly believe that Africa, which has huge reserves of thorium, should utilize its thorium and build molten salt reactors. And instead of Western and developed nations taking advantage of Africa, we should help Africa industrialize, not take advantage. Industrialize in a way that won't be bad for the environment. Work with nature, not against her. If we help the rest of the world industrialize, people will start having less children, and we could start stabilizing the population to around 8 or 10 or 11 billion, and then keep it there, steadily. And you could also help turn the Sahara Desert into grassland. Because here's the thing, Sahara Desert isn't always going to be a desert. Every 20 or 30,000 years, the axis of the Earth tilts, and the Sahara Desert becomes a grassland. And there's a lot of water under the Sahara Desert, groundwater, lots of it. That's why you have oases. In fact, about 10,000 years ago, that's when the Sahara Desert became a desert. It used to be a savanna, and it turned into a desert approximately 10,000 years ago. That's why the Romans been finding lions in North Africa, because of that. It was called a Berber lion, but yes, lions used to roam into North Africa. The reason for this desertification is because of the changes of the axis of the planet, the orbital precession or the Milankovitch cycles. That was the reason for that. So in about another 20,000 years, the Sahara Desert will once again become a grassland, as because the rain belt's going to shift further north. So you're going to have monsoonal rains in the Sahara. And already I've been noticing this time around, there were significant thunderstorms in Mauritania. The southern part of the Sahara Desert has been getting thunderstorms rolling off of Africa in the Sahara. So that's what would happen. The thunderstorms would shift north and then south. The tropical waves that would roll off of Africa sometimes it will be further north, sometimes it will be further south. Sometimes it will be as far north as like most of the Sahara, and then in the winter you will get the jet stream will go further south, especially during colder periods. So the Sahara Desert would get monsoonal rains and then rains during the winter. So its dry season will be very short. And that's how you had Lake Chad being a super big, Lake Mega Chad or Giga Chad, talking about the lake. Lake Chad is about only 20% of its full size when the monsoonal rains shift further north. At its full size, Lake Chad was the biggest freshwater lake in the world. It's already one of the biggest, but... So, that's natural climate change because of how the Earth rotates around the sun. But we can also use the Mediterranean Sea and the oceans to desalinate seawater using graphene to help pump water into the desert, which, to spur more growth of plants, more trees, to help reduce carbon and feed a growing population. And you're working with nature. While instead of against her, you're helping nature, instead of using nature, instead of like digging for resources, you're working with nature, trying to help reduce the amount of carbon in the atmosphere, instead of building machines to do it. Work with nature. Prioritize nature, not businesses. We need to prioritize. When I was in school, we were told that we were the stewards of the planet and we should act like stewards of the planet. Prioritize the environment over everything. Prioritize preserving the Earth's biosphere over everything. Reducing our impact on the environment. Undoing the damage that we have already done. For an instance, in the Sahara Desert, people were planting trees. We need to plant trees as much as we can, especially in areas that have been stripped of trees, especially in countries like Haiti, where there's almost no trees around. This would help with the mudslides, with the flooding, because the trees would absorb all the water. But also work with nature, like how the First Nations, the first peoples did here. They made sure that there was no too much overgrowth, so that if there was any forest fires, it would be manageable. The United States, in its early years, especially in the early firefighting years, would try to squash every forest fire that came around after a particularly tragic fire that happened in Montana in the early 1930s. This caused the forests in the West Coast to become overgrown, and a fire would spread out of control because it would go from the smaller trees to the larger trees. So instead of trying to work against nature, we need to work with nature, not against her. By getting rid of overgrowth in the forests, it would make the forests healthier and make forests live longer, and then plant new growth trees to replace the old and decaying trees. New growing trees actually consume more carbon than older trees do. So we need to plant more and more and more trees wherever we can, especially areas that have been deforested either by natural means or most likely artificial means. So, for example, the Amazonian rainforest just had one of the worst years because of Jair Bolsonaro's policies of reducing the protections for the Amazonian rainforest, which is extremely tragic. And this was the worst year in Amazonian rainforest since the colonization started of the Amazons, the Amazonian people. Brazil started colonizing the rest of the Amazonian rainforest because of Jair Bolsonaro, and it's just terrible. But thankfully, the current president Lula, is standing down against the destruction of the Amazonian rainforest and reenacted policies protecting the forest. Anyway, I'm going to be here for a little bit. I have to be going. I am leaving in a bit. I'm continuing the climate strike. There we go. It's not upside down anymore. So I'm going to be holding the sign up. Here's my bike here. So yes, I don't drive, as you know. I don't own a car, and I really don't want a car. And if I do get a car, I'm going to get the least harmful car for the environment possible, if I ever do get a car. Probably a hybrid or a really small car like a Mitsubishi Mirage, because car with small engine is better for the environment. I'm not sure what car is better for the environment. Is it an EV or is it a small gas-powered car? Because, we don't know how much lithium mining is doing to the environment. But if there was a car that would use graphene or carbon-based batteries, that's far better for the environment because you're trapping the carbon and then recycling it. In fact, carbon-based batteries can could last much longer in terms of battery capacity than lithium-ion batteries do. So, So carbon-based batteries, specific lithium-air batteries like lithium air, are solid-based batteries, and they're not prone to temperature or cooling, and they last much longer, which means less mining needed. Lithium-ion batteries are very bad for the environment because of how they work. Chevrolet are doing Ultium batteries, which are actually far better for the environment. They are less fire prone, they would likely last longer and hold charges more. But there is a problem with the Ultium batteries, is that they catch fire, but they fix that issue. Lithium air batteries don't have the fire risk, even the same as Ultium batteries or lithium ion batteries. Lithium ion batteries would not have the issue of exploding or sparking when exposed to oxygen, because lithium ion batteries lithium air batteries already use the air, and they're far better for the environment than lithium ion batteries, which have like a liquid membrane inside. That's why in cooler temperatures they work worse, because in warmer temperatures the electrons flow easier. But with solid batteries, it doesn't matter whether it's warm or cool, they would flow the same. I think the future is actually graphite or graphene batteries. It used to be theoretical until it was discovered how to do it. And it's actually really easy how to make graphene. The graphene batteries are the future. Graphene is the future. It would make holograms actually a reality. It would make transparent screens reality. It would make perfect for protection for space exploration. It would do so much good, especially for the environment. But it's a new and emerging technology. Well, not technology, new and emerging. Not market, but a new and emerging, technology, new and emerging trying to find the right word, new and emerging, technology, because it would change, it would radicalize everything, from energy storage to parts in your phone, to even space exploration and shielding, especially solar shielding. It's incredible. And we can all do this and protect the planet. Stop using carbon, stop destroying the planet. Build high-speed rail networks across the country. In fact, there was a guy named Lyndon LaRouche who wanted to help Africa industrialize. He's an amazing person. He was a Marxist, I believe, and he wanted to, decolonize Africa, help Africa, escape its legacy of colonialism. But right now, unfortunately, France, but there have been all these coups in Africa, which are finally, I believe, the good thing, because it's helping Africa shake off it's helping shake off neocolonialism, which is really good. And instead of working against their former colonies, the entire world should help Africa industrialize. We need to help the entire world, industrialize, or not just industrialize, but improve their quality of life, such as getting them clean drinking water, food. We need to help lift people out of extreme poverty and extreme just suffering, especially in countries like Somalia, Sudan, Chad, Libya, Mali. And by doing this, we will not only be helping improve their quality of life, but helping the planet by helping them industrialize in a green way. not cutting down their forests. Because one of the most healthy rainforests in the entire world is in Africa. We need to protect those rainforests at all costs. We need to protect the biosphere. We need to help them industrialize in a way that won't have them encroach into the forest. Vertical farming, for an instance. Using greenhouses, using that you could grow crops all year round, indoors, and in adverse climates, without harming the environment. There is so much we can do. There are so many ideas for helping the planet, and no one is doing it. They're talking and talking and talking, but they're not doing anything. This is why I'm out here protesting. This is why I'm out here striking, so people will actually do something. Do something. Don't just talk and say you'll do it. Do it. I'm not a policymaker, but there are so many ways that we can improve without having to spend all this money on just greenwashing. Like ExxonMobil, for instance. I saw an ad for ExxonMobil about how they're trying to help the environment. Well, I'm done with their greenwashing ads. Look, we need to stop manufacturing fossil fuel powered cars. We need to stop. Look, for all those energy companies that are, getting money from fossil fuels, well, stop thinking about yourselves. Start thinking about other people. Start thinking about how to help the planet. Stop thinking about your bottom line. Stop thinking about your pockets. And start doing something. Do something with all that money that you have. Stop hoarding it and pocketing it. Do something with it. Don't just throw your money at anything. Oh, look, that's a good idea. Let's do that. No. Research. Research and do the right thing. Such as, instead of giving money, let's give that money to that organization. No. Invest in green energy, but in such a way that it won't do more harm than good. Don't just say, let's invest in wind and solar and start cutting down all these trees to build wind and solar. No. Do it in such a way that maybe putting solar panels on someone's roof instead of cutting down trees. Or if you want to build a nuclear power plant, don't build today's ancient nuclear, pressurized water reactors. Build molten salt reactors that you don't need all these resources. You don't need to go mining for it because it's already been pulled out. So there are ways we can do this. We know that we're causing climate change. Now let's do something about it. Stop mining lithium. Stop mining lithium, just strip mining everything. And stop exporting your labor to other countries. Mine it yourselves in such a way that it won't harm the environment, or reuse batteries, recycle them. But still, that's the better idea, is to work with nature, not against her. For example, that phone that I'm using is 3 years old. It's broken, it's fell multiple times. Instead of getting a new phone, I just replace its parts. I'm trying to keep this phone going for as long as possible. Maybe another 2-3 years before I need to replace it. Or instead of getting a whole new phone, why just not get a new processor? Like your chain falls off, get a new chain, don't get a new bike. Your engine died, don't get a new car, get a new engine. It's practical and it's good for the environment. For an instance, when people back in ancient history, when something would break, like an axe would break, instead of replacing the whole axe, they would just get a new piece and install it. And over time, parts would change. We need to do more to help the environment. We need to stop this consumerism. Stop saying, I want the latest iPhone, or the latest this, the latest that. We need to stop with this consumerism. It's destroying our planet. We need to stop. with consumerism, with greed, with wanting everything new. We need to help the planet, not ourselves. We need to do something. When I used to go to my special ed school, I was screaming to them, begging them to install solar panels for years, but they said they didn't have enough money to do it, which of course wasn't necessarily true. But I did manage to get something done. It's one of my only accomplishments. I got the school to start recycling paper and plastic. And I was only 15 years old at the time. Actually 16. This is back in 2007. I am 32 years old and I'm a student, so I'm still a school striker. And when I found out about Greta Thunberg, and what she was doing, I actually cried tears of joy. She became what I wanted to be, but I couldn't do it because I was in a special ed school where I couldn't really become a well-known climate activist. I was in a sporting school for children and young adults with autism. I wish I did what Greta Thunberg did earlier, to help the planet. But the fact that she stepped up and did what I couldn't do, she's a hero. And we need more people like her. And Greta, thank you so much for everything you've done, for all of the hate that you received. Your wittiness is just amazing. I mean, the fact that so many people, do you know why they're doing this to her? It's because they are scared of her. They're scared that a neurodivergent child is better than they are. They are jealous of her. They are jealous that a kid who has disabilities has done more than they ever would dream of in their lives. So yes, they are jealous of her. Fox News and all of those political talkers who are talking smack about her are just jealous. And yes, she grew up wealthy, but she didn't use her privilege to be selfish. She is an amazing person. And I did not grow up in privilege, but I knew how precious the earth is. I don't want our future generations to live in a planet that's unlivable. I want our future generations to have a planet, to have nature, to be able to go to the ocean and see birds, and not go to the ocean and just see nothing. I saw Earth 2100. I saw it. Earth 2100. And if we don't do anything, that will happen. The bad ending is going to happen. We need to act. We really need to act. And not like, let's do slowly. We need to act as fast as we can. We need to stop allowing corporate greed to rule our planet. We need to stop allowing greed to rule our planet. We need to think about the planet first, and then ourselves. We don't come first. No, this planet is what comes first. The planet comes first before everything. The health of this planet comes first before everything. Naples, Italy, for instance, is sitting on borrowed time because there are two volcanoes there. Vesuvius, but another even more dangerous volcano called Campi Flegrei. There's a chance that volcano one day could have a VI7 or VI8 eruption, which would actually be the worst disaster in Europe, because it would not just affect Italy, it would affect all of Europe and perhaps the world with a possible volcanic winter. And there are many ways nature can do more damage than we can. But as of now, we're doing more damage. Nature always finds a way to come back from disasters, such as a volcanic eruption. Volcanic ash is very fertile. Nature, here's the thing, nature emits more CO2 than we do, but then it also reabsorbs it and strips it away through weathering. So that nature was in balance. We destroyed that balance because we are emitting more. Let me give you a good history lesson here. For all of you who didn't know, 250 million years ago, there was a flood basalt eruption in present-day Siberia. That hotspot is likely the Baikal hotspot located around Lake Baikal. So 250 million years ago, there was a flood basalt eruption. That eruption lasted for several million years, but near the end of the eruption, something changed. A magma intrusion failed, so it was a dike intrusion event. D-I-K-E. A dike intrusion is basically a failed magmatic intrusion that doesn't make it to the surface. But what it did was it was just below the surface, and it ran along coal seams, burning them all and releasing huge amounts of carbon into the atmosphere. All of this happened within a few thousand years near the end of the eruption. How much carbon was emitted? It was unfathomable. The CO2 concentrations in the atmosphere went from about 500 parts per million to almost 7,000 parts per million. The CO2 concentration in the atmosphere went from about half of a percent to almost 0.2%, and this caused the worst mass extinction event in the last billion years. You think the asteroid impact that caused extinction of dinosaurs was bad? No, it was worse than that. It was worse than the Chicxulub impact. It was a lot worse than that. It was the worst mass extinction, in fact, in all of all of Earth's history, because there were so many species that went extinct. 90% of oceanic species went extinct. 75% of all land species went extinct. The cause was a dual combination of severe global warming combined with massive acidification of the oceans from all the carbon that was emitted. If we don't stop, that could be our future. We need to act now. We are only about 100 years away from reaching 1,000 parts per million. We already exceeded 400. We've actually surpassed 420 parts per million. When I was born, you know what the CO2 concentration in the atmosphere was? It was around 350 parts per million. I was born in 1991, when CO2 concentrations were less than 360 parts per million. Now, they are 420 parts per million. And the rate of increase is only going faster because of all the developing nations turning to fossil fuels. Instead of punishing those nations, we need to help those nations industrialize in a green way. Wind, solar, energy storage. Elon Musk has got to do more than his transphobic agenda and actually help with energy storage. Instead of selling it to them, he should give it away for free. We need more people to start developing energy storage solutions for renewable energy, especially in developing countries. We need to do this. Our planet is too precious. It's not just the surface. When I say the planet, I mean the biosphere. It's too precious. We need to preserve nature. We need to preserve, the biosphere. Not just for us, but for everybody, for everything, for all life. We need to be prioritizing the rights for other species to live and not die either by our hands or by ulterior means. We need to take care of our planet as if Earth is literally our mother. what would you do if your home or your mom was sick? Treat your environment like you would another person, with kindness, with delicacy. Be delicate to your planet. Be delicate to our planet. And please,
No, you're fine.
be delicate to your planet. Care about your planet. And don't just go to protests. Do more. Write to your politicians. Write to your energy companies. Write to vehicle companies. It's not just governments. We need to convince automakers, cargo companies, all these freight lines in America, saying, hey, the climate crisis is here. It's not that it's coming. It's here now. Remember saying, oh, the future generations are going to be dealing with it and it's going to be getting worse? Well, we are the future generation. It's happening now. Look what happened in Florida. Look what happened in California. Look what's happening all around the country with this triple-digit heat. Not just triple-digit heat, over 110 degrees. I've been looking at the forecast for the next week across the country. South Dakota, North Dakota in 110s. In this deep south, my friend is dealing with all this, and this heat is causing the oceans to warm up because all this heat that's in the land is transferring to the oceans. Not only that, the Gulf Stream is already shutting down. There's already the cold anomaly off of Iceland because the AMOC is weakening. It's on the verge of shutting down, which will plunge Northern Europe into brutal winters. So yeah, while one area of the world will experience brutal winters, the rest is going to be scorching hot. Please, do something. I will be here every Friday, and others will be joining me as well. There are so many ways we can help the planet, reduce, the climate impact. We need to look at spurring phytoplankton blooms in the oceanic deserts, just small enough that it will help absorb the carbon, but not to the point that it would become an uncontrollable algae bloom. In fact, when the Hunga Tonga eruption happened, there was a massive phytoplankton bloom because of all the nutrients that were released from the eruption. In fact, one of the reasons why the Amazon rainforest exists at its current capacity is all the nutrients from the Sahara Desert that gets blown by the trade winds. However, when I say turn the Sahara green, I don't mean turn every part of the Sahara green, just certain parts of it. We would never completely get rid of the desert. Even during the wet part of the Sahara, there was still parts of the area that were desert. We need to invest in our planet, help nature recover. And by spurring small plankton blooms in oceanic deserts, it would increase biolife there. First it would be the algae, then the fish would come, and you would help the ocean recover. But the problem is, in the Gulf of Mexico, you have something known as dead zones because you're releasing so much nutrients that you're triggering these massive plankton blooms to the point that it becomes toxic because once they die and decompose, you're sucking all the oxygen out, which is causing the dead zones by getting rid of all the oxygen. We need to stop doing that because that reduces our ocean's capacity to absorb carbon. The Atlantic has one of the best carbon absorbing capabilities of any ocean. In fact, it absorbs more carbon for just the Atlantic than the Pacific Ocean in its entirety. Part of the reason is because of the Sahara Desert. If we can sprinkle some plankton across the Pacific Ocean, we could help increase the Earth's carbon absorbing capacity. So we're working with nature, not against nature. And this would increase the biolife. So the purpose of this should not be to take the fish out of the ocean, to continue this these trawlers It's to help recover marine life, just so Earth can be healthy. Not for our sake, but for the planet's sake. We need to do more. We need to do more. Thank you for watching. And right now I gotta go. I'm going a little early because I have an event I have to go to, but I will be here every Friday from 2 to around this time. Actually, maybe from 1. And on the 18th, there's gonna be no school, so I might be here all day Friday. So thank you all, and love to the planet. And whoever's watching, please comment, because I know there's only one person watching right now. I appreciate you being there.